Good morning, everyone. Good afternoon, good evening, depending on where you are in the world. We are going to give folks a few minutes to join. While we wait, type in the chat box, tell us where you're calling in from and what role you hold in your organization. All right, quite a few people filling out our poll. Thank you so much. Hello from Denver, California, Atlanta. A lot of folks spread across the US.
Austin, Texas. You think we're going to get anybody from Pacific Northwest in the middle of bomb cyclone if they have power?
Ooh, I don't know.
Chandler.
Hello from Denver. Most of us on the call here are based in Denver. Awesome.
San Francisco, Pennsylvania, Chicago.
Wisconsin. I was just in Wisconsin last week. It was very gray.
I was
Don't
just in
like that all the
Chicago.
time, but it was very gray.
Germany, there we go. Some global attendees.
San
Yeah,
Jose.
guten Tag.
Guten Morgen.
I mean, it's probably afternoon there, yeah? Or almost evening.
You're right.
Guten Nacht. Guten Abend, maybe. I don't know. I don't know what time it is. I can't do math.
Yeah, I feel like it's at 8 hours, 6 hours, 8 hours ahead of Denver. India, Canada, New York City. I'm headed there this afternoon.
Why are you going to New York City, Morgan?
Thanks for asking, Scott. I'll be
Yeah, no
walking
problem.
in the Macy's Thanksgiving Day Parade.
Oh, that's
Gosh.
awesome.
You can catch me escorting Tom Turkey, the first float. I'll be dressed like a leaf. Baited you into that one.
Got Mexico,
Hmm.
Texas. Fantastic.
Great.
8 Uhr auf Deutschland. I'm really stretching the limits of the German I know.
I think you're the only one of us that can speak any German.
Das ist gut. Deutsch ist meine zweite Sprache.
8 p.m. There we go. So it's nighttime over there. Thank you to whoever translated the time zones for us. All right, I think we can get started. We have quite a few attendees here. It's a little earlier than we usually get started, but based on the poll and the call-in responses, we can definitely kick off. Just a reminder that the recording of this event and the slides will be shared via email after the event ends. And we do have a special promotion for today. So of those who stay till the end of today's event, 100 of you will be randomly selected and win a $20 lunch gift card. You'll be notified via email, so keep an eye on your inbox. And with that, I will hand it over, I believe, to Scott to kick us off.
I think that sounds right. Thanks, Morgan. Thanks, everyone, for joining. Brian and April are going to take us through a really cool GitHub and StackHawk demo and office hours. Ask a lot of questions, keep it interactive. They love answering questions, especially very hard technical questions. It's probably the best thing that you could ask. I just wanted to say thanks for coming, and I'm super excited about this particular office hours. GitHub is probably it's definitely my favorite partner that we work with, technically and from a like, how do we attract customer type of thing. But technically, GitHub is the very first thing that we have always built. Every time we have an idea on how to do something, we build it with GitHub first, which is why stuff like our SAST correlation engine is so awesome. Like, it is the only thing that can point you at the line of code that you need to be fixing if SAST and DAST find it together. Our integration with GitHub Actions is first class. It's super awesome to be able to wire up StackHawk to be able to run as part of a PR, get comments back into a PR, schedule scans, that kind of stuff. That also works with Azure ADO, but today we're talking about GitHub, as well as like handfuls of other stuff, including our super awesome and first in the industry API discovery feature, which helps you connect your GitHub repositories to StackHawk. And we will actually go through the code bases in there and find APIs that code is building and help you understand what APIs you should be testing, how many there are, how big this problem is, whether they're internal or external or internet facing or only an intranet kind of a thing. Our API discovery was built on GitHub first, and it's the only and best in class API discovery based on source code that there is. So I'm super excited to have everyone here. If you have questions about any of these things, like I said, please ask. Brian and April are going to take you through a really awesome kind of more details about what I was talking about. April's going to take you through a sweet demo. And it definitely won't go wrong at all because it's live demo. So I give you the thumbs up on the demo gods. I've prayed to the demo gods for you. So I think that's all I got. Brian and April, please take it away.
Thanks, Scott.
Yeah, thanks, Scott. So as Scott said, I'm Brian, and this is April, and we are part of the StackHawk team. I'm a senior product manager, and April is one of our solutions architects. So a little bit about StackHawk itself, and Scott talked a bit about our partnership with GitHub. We were created in 2019, really with a mission to automate API security testing. We're one of the champions of shift left API testing, and one of the only DAST solutions that runs in CI/CD and is a developer first security trusted DAST solution. We're really built to help developers and security find and, most importantly, fix vulnerabilities. And we want to work with security testing, or we do security testing for teams that deploy software every day. So the idea is, how do you keep up with those code deploys that are happening multiple times a day? With CI/CD, they're getting deployed into production, and you want to be able to confirm that there are no security issues going out and being exploited in production. So we're here to help you get those things discovered and fixed before that happens. And so April, lead us off with our first poll here.
Yeah, so we've got another poll. Poll question number 2. How many folks are familiar with DAST scanning, which is what StackHawk does in particular? Are you super familiar? Vague acquaintance, never heard of it? Let us know. And we have a couple questions. I'm not sure about Maureen's question, how to confirm the duration and agenda and timing of the sessions.
Maybe just how long are we going to go for? I think about 45 minutes to an hour, depending on questions.
And then another from Lynn James. What are the main benefits of addressing security issues from code to runtime using GitHub and StackHawk together? Which is a great question. And really, there's tons of benefits. Obviously, we'll talk a little bit more about all these components of your AppSec security program, but it involves static testing, dynamic testing, and if a lot of times people are looking for an entire platform that combines all of those things. And these are all tools that can work in your build pipelines and can all give your developers really fast, actionable feedback. And they integrate super, super well. Scott, do you have anything else you want to say about this?
You surprise question me. That's a good one. I like what you've done here. Literally spend 10 minutes talking about what I'm going to do. And then you're like, and I added one at the last minute. I think the really cool thing for me, like, you know, my history is as a security operator, right? I worked 10 years at GoDaddy, 3 years at SendGrid, and security is oftentimes a firefighting exercise. Like, it's very reactive. A fire starts and you go try to put the fire out. The thing that we strive to build, and I think we did a really good job at StackHawk, is how do we get ahead of the fires, right? How do we make sure that we're not building APIs and applications that have flaws in them before we put them on the internet and make them available to people? So the analogy there is, how do we make sure that we're building houses out of non-flammable material instead of straw? Maybe, I don't know what, I don't know. Other things are flammable as well, but that's probably the main benefit, right? Is being able to connect the code that is going to turn into an API or an application, be able to see it before it gets deployed to production, and be able to say, we tested it and it does not have immediate instant, like, you can't test for everything, right? There's no silver bullet. It doesn't have immediate instant exploitable vulnerabilities that are just going to put us into firefighting mode again. So I think that's the number one benefit. The number two benefit is connecting our security teams and our developer teams. And that is so hard to do. Take it from someone who's tried to do it. It's so hard to do when you're reacting to stuff that's been published on the internet and is now being attacked. And you're like, who knows how this works? Who's working on this code? Who can help me triage and react to it? And being able to see these two things tied together, and that's like source code and what it turns into in runtime and what it does, really helps in the case where you end up having a response, making the response more efficient. I know who works on this API or this application, and I can go to them to ask for help in a response type of a situation. Good question, even though sneaky.
Thank you, Scott. Appreciate that. And it looks like we've got a ton of responses. Looks like most people are, definitely familiar with DAST, and many have used it. A lot are experts, so that's great. It's great that you're all coming with context. I don't know if you've seen StackHawk DAST. It's a bit different from the DAST that you probably are used to. But why don't we move ahead and hopefully it'll become more clear as we talk about it. So now I want to talk a little bit about all of the tools that go into GitHub Advanced Security and StackHawk. SCA, SAST, and DAST. So given that most folks know what DAST is on this call, you probably know what SCA and DAST are. But just to talk through it really briefly, GitHub provides Dependabot with it, which is a software composition analysis tool, or SCA. And that is a very fast kind of check that is easy to automate in your build pipelines. And what it does is just check your dependencies that you're pulling into your software. And it checks those dependencies, especially third-party software dependencies that you're used to seeing or that are common. And it checks them for known vulnerabilities, CVEs, common vulnerability enumerations. And when it sees them, it can report on them. There's really no false positives because they're all absolutely known vulnerabilities. However, I say it's sort of no false positives because you could pull in one of these vulnerable libraries and never really expose that vulnerability in the runtime, which is an important concept. So that's Dependabot, and it's part of GitHub Advanced Security. It's very fast, really easy to implement, really easy to solve for as well. Dependabot will actually just open a PR for you to fix it. SAST, so GitHub Advanced Security has CodeQL, which is their static analysis tool, static application security testing. And this actually looks at your static code base and analyzes it for vulnerable patterns or code smells. And it's looking for things that could lead to runtime vulnerabilities, and it will report on those. And one of the big advantages of it is that it's a little bit slower than SCA, but it's still relatively quick. And it finds your bugs that you've written. And so it's finding, issues that aren't known in the world yet. And it can show you exactly where in the file, like which file and which line this vulnerability or this bad pattern exists. And they can give you a full narrative around it that explains what's going on. It's very, very actionable. But one problem with it is that it will show you a lot of results. It's a huge bad news machine. And not all of those results really result in an actual runtime vulnerability. So super actionable, really detailed, pretty quick, easy to automate. Those are the advantages, but it can't tell you about runtime vulnerabilities. And that's where DAST comes in. That's StackHawk, that's what we do. And as opposed to looking at your static code, it actually looks at your running web application. And it will attack that running web application. And as it is able to, it'll run a battery of tests against it. And as it tries to exploit vulnerabilities, it'll report back to you on the ones that it finds. And when we have findings, as long as the scan is tuned, you've got a good policy, you've got good fast network access to the application, it's going to be very low false positives, and it's going to show you true runtime vulnerabilities, and it's going to report back to you exactly how you can reproduce that vulnerability. And with StackHawk DAST, we've made that very, very fast. There's a lot of tricks to that. We won't go into it here. It's a little bit out of scope, but basically we've got a really lightweight, simple Java-based scanner that you can run in pipelines, you can run in your QA workflows, wherever you need it. It means you can get it very close to the application, and you can tune it down to get very, very fast and impactful results. One thing I want to note here is that SAST and DAST, if you notice, is they have a really nice set of trade-offs, complementary trade-offs. So SAST has a lot of false positives, but it can show you where in the code the problem is. Whereas DAST can't show you where in the code the problem is, but it can prove that it's a runtime vulnerability. So we'll talk about this later. If you can combine those two, you can get directly from runtime to line of sight to the exact line of code that caused that runtime vulnerability. We'll talk about that in a little bit. All right, next, I think we will talk about all the different ways we integrate with GitHub. Right?
Awesome. Thanks, April. I love that bad news machine. That's a good, gotta keep that for later. Okay, so we've talked a bit about what StackHawk is, who we are, a bit about the technologies that go into securing your code and your applications and APIs. And so today's topic is all about how StackHawk and GitHub work better together. And this is a few of the areas. We're going to cover each of these in a little bit more detail, but we start with AI-powered API discovery. We are able to connect up to your code as the source of truth, identify those repositories that are an app or API, and give you the oversight into whether new ones are coming up and governance over your testing program so that you know what to test. Then we move on to how do I test it? And that's where we get into the GitHub Actions integration that Scott mentioned. From there, we take the results of that, and rather than just shuttle those up into our platform, making people go there to find out what happened, we get the results. Not only did a test get run, but what are the results directly in those PR comments, as well as bringing those DAST code scanning alerts into your GitHub Advanced Security dashboard so you can see all of your vulnerabilities together in one place. And lastly, as April just talked about, we also correlate those dynamic findings with the static findings so you can know what's exploitable and where in the code it is. So let's do another poll. April, you want to kick us off?
Yeah, so as regards that API discovery piece of the equation that Brian just talked about, how confident are you in understanding your API attack surface and its rate of change? So this is something that comes up often. I don't know if we've put the poll up, did we?
It's up, yeah.
Okay, cool. Yeah, so a lot of times we hear from folks who are concerned about all of the APIs out in their organization, especially if it's a large organization. With modern software architectures, you've often got single page apps fronting lots and lots of APIs. It's a different world than back in the 2000s when servlet style architecture was popular. And now we've got mobile apps and single page apps, and they're just fueled by APIs, and it can be tough to find them. So where are you in this picture? Are you pretty confident you know about all of the APIs, all of the web applications in your organization?
Yeah, I think, April, one of the things that I know from just working with a lot of our customers, we've talked to some who, it can take months or even up to, a year of just sort of sleuthing and talking to people to find out, what are all those APIs and which repositories do they connect to. So, this is not just usually a quick task. It can be a pretty long process.
Yeah, absolutely. And we've heard from customers who are managing this by spreadsheet and talking to developers, trying to figure out where they all are and where they're all deployed.
Well, it looks like at least a bit over half of folks are either well aware or feel pretty confident that they're testing what they need to test. So that's good to hear. But definitely some folks who may want to dive deeper. So let's talk a little bit more about that API security testing. So API discovery with StackHawk, this is a relatively new feature that we've developed to help with this problem of what is out there, what is an app or a API, and how do I get it tested? So we're giving you visibility into that by identifying and prioritizing those applications and APIs, giving you that information you can use to help with, as Scott mentioned, the communication between security and development teams. It's like you're having an informed conversation at that point about something that you think that may need to get tested. It also helps with compliance and reporting requirements. So you're able to say, yes, we are covering all of these APIs and applications. And it also keeps you in the loop as new things become developed and are about to go into production so that you can catch them before they're actually in production. So we can get that tested, make sure there's no vulnerabilities going out, maybe, and having these sort of zombie APIs sitting in the public untested. And just generally the goal here is to improve the performance and relevance of your application security testing program, so you can present that both up to folks in your leadership teams, as well as talk to your development teams about what needs to be tested. So, and next, I'm sorry.
Yeah.
Is that right? No, sorry. So April, how do we actually get these applications and APIs tested once we've identified them?
Yes. So this leads to one of our earliest integrations, which was our HawkScan action that we built for GitHub Actions. So it's a fully fledged action. It's available in the GitHub Marketplace. It is the deepest CI/CD integration we have, and we've got integrations with a number of different CI/CD platforms. And it really gives you the ability to very quickly implement StackHawk in a build pipeline in GitHub Actions. Very simply, you can just say, hey, I want to run HawkScan. It will take care of installing it for you. You can set it up in a mode that you kind of take manual control of it and run it yourself as a script step. But most of our customers just use it as the action, and the action can run it itself, run the scanner itself. It's got features to enable, unlocking a lot of our features like advanced logging, advanced output, and even output to a serif format that I'll show a little bit later that can help you actually post your scan results to the GitHub dashboard. Other than that, it's pretty simple. It's just a really fast and easy way to implement this in your pipeline. But it ties in as well to another integration that we've got, which is our pull request checks. And so this is how you can see scan results directly in pull requests.
Yeah. So pull requests, when we're talking about getting into the developer workflow, really important to have that context, to be there at the right time and to be there in the right place. So what we talk about with pull request checks is we're able to update that action to connect to an actual specific branch and pull request, show that the security testing has run, it ran successfully, and whether there's any findings, and getting those findings into the PR itself, rather than, say, like we talked about before, having to go to another platform to see what the results of that test were. So the developer sees the PR comment, it's got all the information they need to make an informed decision as to, do I need to fix this? What is the issue? Where is it? Get that fixed, retest it, and deploy that PR, or merge that PR and deploy it with confidence that there are no security vulnerabilities going into production. So April, how do we get those findings? Speaking of getting them out of our platform, how do we see those in GitHub Advanced Security?
Yeah, so this is one of our, in fact, this is our very most recent integration with GitHub. It's actually an integration with a lot of different products, including GitHub and Azure Pipelines and Azure Defender for Cloud, or Microsoft Defender for Cloud. So we worked with Microsoft and GitHub to update the serif standard. And the serif standard is a file format that enables the security dashboard in GitHub Actions to display static analysis results. So we had played around with that in the past and found that it couldn't accept dynamic results. We worked with them to update that, and now we can post to their dashboard and several other kinds of dashboards that support this new standard of serif. And so the upshot really is that our results can show up right in your GitHub dashboard, and that means developers can see their results right there in the code base, in the repo, where they're living and working every day. And it's just another convenience factor that helps kind of avoid that dashboard fatigue where you have your developers having to jump from tool to tool.
Great.
So next, we'll talk about CodeQL integration.
Yeah, so we've talked a bit about this already, but this is really, how do we take the static results? As April mentioned, it can be a lot. There can be a ton of things. You don't know if all of them are exploitable from the outside. And so when we combine the dynamic test, which does tell you what vulnerabilities are exploitable, and combine that with the static results, we're able to see and reproduce the issue, see where in the code it is, even see the code itself with our GitHub integration where the vulnerability was discovered, fix that issue, retest it, and see that it was no longer reproduced and exploitable. And that really helps connect those dots and make sure that you're not hopping around looking at one thing in one platform and then another in a separate platform. And we'll show a little bit of this with our demo. But before we get to the demo, let's do another poll. Just curious how many folks are using GitHub Advanced Security now, or if you're maybe considering it, or even if you're not. A lot of these things, as April mentioned, we have integrations with almost all the major CI/CD providers. We integrate with multiple source code management systems. So we have you covered wherever you are working, especially with GitHub.
I think we've got a lot of GitHub Advanced Security customers and a lot of folks who are interested in looking at it.
It's great.
And we've got one more question too from Christian Vladut. And the question is, what is the difference between doing this and scanning endpoints with Hawk CLI and running on specific endpoints? And I think you're referring, Christian, correct me if I'm wrong, to the GitHub Actions integration. And really, there's no difference. It's just that we've wrapped the CLI in the semantics of a GitHub action just to make it easier and to make it straightforward to people who are used to that kind of build pipeline. A lot of our customers, it's their DevOps engineers who are tasked with implementing scan configurations. And so this just makes the job easier for them when it comes time to go and set these up in automation. The reality is that action can actually just handle the installation portion for you. And if you're more comfortable with the CLI, you can just use CLI semantics in the build pipeline too. So follow-up question, I can specify specific endpoints and drill down through the tree to provide auth in GitHub Actions as well. Yes, you can. So you can specify, you're talking about discovery, how to find which routes and so forth in the application, and all of that feature functionality is available in GitHub Actions as well. That's true.
Great. So it looks like close to 80% are either using it now or curious about it. So that's really, I guess, good to see for a GitHub focused webinar or office hours. So awesome. Well, April, are you ready to show us how all this comes together?
Yeah, let's do this.
All right, I'll let you take it away.
Okay. All right, so I'm just going to go in the same order as the tiles. And this is all live. I just ran some scans. But I've kind of lined up my tabs to just show the order. All right, so we started with API discovery, and that's what this is. And so what I've done here is I have integrated with GitHub from our integrations page. So under integrations, we show all of the different integrations we have, and each one is pretty straightforward. We'll walk you through the process. Once that integration is complete, we will pull in all of your repos if you give us access to all of your repos, and we will pull them into this page. And from this section, from this All Repositories tab, we'll show you all of the repos that we found, and we'll mark with a purple bar and a sparkle those repositories that we found that actually contain web application code. So these are the things that we have then automatically added to your attack surface. So from this view, we're only looking at the applications or the repos that we found that contain web app code, such as APIs, GraphQL applications, gRPC apps, and so forth. We haven't pulled in these because they are client applications. They're not web application code. If we got it wrong, you can correct us here, but generally we've got a really great track record. And as Brian mentioned, we're also telling you a bit about the frameworks that we found that gave us the clue that this is a web app, something about commit activity, commit frequency, who was the last committer, for instance. And this gives you an understanding of what applications are out there to test, what applications you are already testing, and which ones are yet to test. So those that I've covered, those that I've already set up in StackHawk, we consider covered, and those that are not set up in StackHawk are not covered. And that's how we come to this percentage coverage. And over time, the idea here is to give you the scope of everything that you need to be testing and where you are in the journey to get them all tested. As new applications are found or as repos start to contain web application code, we'll let you know. We'll send you an email notification and let you know exactly when they show up, and we'll adjust your attack surface coverage accordingly. From here, you can view the applications that you've already set up in our oversight dashboard and what your testing progress for that application is.
April, before we move on, we got a couple questions.
Sure.
Ihor asks, don't we need to deploy the application before testing it? How do we perform DAST during the build phase?
That's a great question. So a lot of times our customers will start out testing in QA because they've already got their applications running there. And so often the workflow will look like this. You'll go through the build process and pull request. And when that pull request is merged, you often then have an automatic deployment into your QA or staging environment. And you can follow that up with a DAST scan with StackHawk to that environment. And you can use that GitHub action to run that scan. That's often the first pass. But ideally, you want to actually do that in pull requests. And you're right, you need to put up a preview environment of that application somehow. So a lot of different ways to do that. We have customers who will do that by deploying a preview environment in Kubernetes. And they'll deploy both the application that they just built in the pipeline, as well as any dependencies around that. And ideally, you would also have data stores that are pre-seeded with data that is always the same when you run the scan. So you get very consistent results time after time. So that's one option. It's kind of complicated. Other customers will just run it on the build agent, or you could deploy it to that QA environment as well, test it there, and then continue working, or they'll have a development environment. So you're right, you do need to have the application up and running, and we can help with that kind of setup. So those are batteries you definitely need to bring. I hope that answers the question.
One more, maybe let's see a little bit more, and then we'll answer some more questions. How about that? Sure.
Okay, so we talked through this. You can also connect applications from here and begin to configure them. And we'll walk you through either creating a brand new app, or maybe you've got an application already under test and you just want to connect it to that repo. You can do that from here. So that's attack surface discovery, and it ties very deeply into GitHub. Next, I want to show pull requests. And I see the one in Q&A. I'll answer this one. Seeing a lot of movement towards IAST and a little bit towards RASP. Wouldn't IAST cover the benefits of DAST too with a little amount of setup curve? So they're both trying to solve the same problem, where you're trying to get from a runtime vulnerability down to a line of code. And we think that our approach is better because you're getting the benefits of a classic DAST scan. You don't have to instrument, you don't have to implement libraries into your code base, manage these different profiles between pre-production and production. And we're accomplishing the same thing with our SAST and DAST integration, the CodeQL integration. So check them out. We think this process is a little bit cleaner and more straightforward, especially if you can get developer involvement, because one of the power tools with StackHawk is that you can get developers to help you with the scan configurations. It's a very developer-friendly tool, and it's a way to also get developers into that security mindset, help them understand the issues, use it as a code quality check tool. A lot of them end up enjoying it so much that they use it locally on their own workstations. All right, I want to go next to pull requests. Or actually, no, I was going to go to our actions integration. So this is the StackHawk HawkScan action on the GitHub Marketplace. And just to show you that this is where you can get it and learn all about it. We'll tell you about the tool. We've got tons of great examples, detailed documentation. Thanks, Sivas and Gar. And so this should help you very quickly get up to speed with how to use the integration, including some tweaks here, like setting different configuration parameters. I've set that up in my own build pipeline. So here is an application vuln node express. I've got my GitHub repo open, and under .github/workflows, I've got a HawkScan file. And this has just one job that builds and tests my application. So here I've checked out Node.js so I can build my Node.js application. I've installed dependencies. I've run unit tests on my app. And then I start the application up. So this is my preview environment. In this case, it's very simple. I actually don't have a database behind it, but I could run that as well. So I
So April,
sorry.
one question. So these are the same kinds of things you might have to do to, say, run integration tests and other types of QA testing processes?
That's exactly right. So you've probably already got in your build pipelines all of this, everything that builds up to installing and building your application and then running unit tests on it. So I've just added running the application itself. You could add a few more steps to run dependencies as well. Next, I run HawkScan. So I've run this in the background with the ampersand. And so now the application's up and ready to test locally. Now I run it and I'm feeding it some environment variables that I'll use later. So a commit SHA and a branch name to tie into our PR integration. I'm setting these no color and no progress flags. Normally when you run the CLI locally, it's got a lot of beautiful output. I'm just suppressing that because in the build pipeline logs, I want a clearer log, no noise. Serif artifact true, I've done that so that I'm producing that serif artifact that will allow me to then upload the serif file to GitHub so that my scan results will show up in the dashboard, in the security dashboard. So pretty straightforward. We're just using the HawkScan action. We're going to pull in an API key so it connects to our platform and pushes results to it. And the rest are just options. That's what that looks like. And then it's a different file. So then here is a pull request that I've opened. And the pull request is exercising this build pipeline. So in the pull request, notice that once the pull request has run through and it's done all of its testing, I've got a comment now that shows me that I've got a complete HawkScan. And in this case, I set it up to fail if it finds any new security vulnerabilities that hit the threshold of high severity issues. We use the OWASP rating framework. And so this scan did have a high severity issue. And so it broke the build. And I can jump to the results in StackHawk, but it's nice to know that you can also look at the vulnerability details here. So I can see that I've got high severity issue cross-site scripting vulnerability and a SQL injection vulnerability. And I found that on the search path. This one was also found on the search path. So that's the pull request integration.
So April, maybe this is a good time to answer one of the questions about what are the types of exploits and attacks that GitHub and StackHawk can identify? And then I think following that is, can it perform automated remediation?
Yeah. So we both look for a lot of the same types of vulnerabilities. And I'm sure they've got a write-up somewhere that describes all of the vulnerabilities that they check. I'm not sure where that is offhand, but we also have that list and it's here in our documentation, docs.stackhawk.com. And here you can see all the different plugins we're running. So we're looking for open redirects where we're able to cause the browser to redirect us to a different site. Directory browsing, are we able to break out of the directory that the application's running in and find others? Can we exploit shell shock, path confusion, SQL injection vulnerabilities, lack of SSL, proxy header misuse, lots and lots of different vulnerabilities. It's all available here. Maybe I could post that to the chat. Very comprehensive scanner. Okay, so this ran, I got good results. I've got my scan data present right in the pull request comment field. Now I've also posted my results to the dashboard. So these are those serif results. I can actually filter this by tool. So I've got a CodeQL result in here detected by CodeQL. And I've also got several StackHawk results. So these are all of the StackHawk results. and you can click into each one, and we'll talk to you a little bit more about each one, and you can bounce out to the results from here and look at them directly in our platform. So now this is our platform that we've taken you to. And all of this just to show you that we can push our results into this security dashboard so that your developers can see them right where they're working. Next, excuse me, I want to show you these scan results from our platform. So we're back to our platform. I showed you attack surface. I showed you a little bit about our applications oversight dashboard. Now I'm going to jump into our scan results. And this is a scan that I just ran recently for this same application, Vulnode Express. So we've got all of our findings here. Notice that in the SAST column, I've got a GitHub icon for this SQL injection finding. And what happens is that every time we're checking for DAST results, we will check with the GitHub API, and we can pull in their results here as well. So we can show the user now. So imagine you're a developer and you're coming across this because it broke your build in a PR. You can understand the vulnerability. You can understand the evidence behind it, the request and response data that you need to use to exploit this vulnerability, which, by the way, you can also validate with a curl command, so you can actually run that attack yourself. But now, in addition to that powerful tool that you've got that shows you the runtime evidence and gives you that reproducibility information, so you can reproduce the attack and start to work on it, we can point you to the actual file now. You should look at the search.js file in your repository, and you should be looking for line 6. And if I look at my CodeQL details, I can actually pull that up and get all of that detail, just like what you're used to from CodeQL in GitHub Advanced Security. So this is amazing, again, because DAST shows you runtime results. It's provable, it's reproducible. The downside is we can't show you the code level detail. With static analysis, it's the opposite. They found this pattern that indicates that there probably is a runtime vulnerability, but they can't prove it. So now these two are agreeing with each other. That's powerful. And you know it's a runtime vulnerability, so you should work on it. It's prioritizable. And finally, you can look at this code level detail, and this helps a developer very, very quickly fix it, especially if you've got Copilot enabled, in which case you can just generate a fix from here. So that's the CodeQL integration, and that is the end of my demonstration. It looks like we got one more question.
Yeah, I was just about to ask if you want to take a stab at that one.
How does the integration between GitHub Advanced Security and StackHawk manage potential conflicts or redundancies between SAST and DAST findings? What mechanisms are in place to ensure that developers aren't overwhelmed with duplicate or low priority issues? So we think that the answer to that problem of being overwhelmed with too many results that aren't really actionable is actually to run DAST in your pipelines, because from our scan results, we're sort of showing you pretty minimal results. Everything that we find is essentially proven in the runtime because we were actually able to exploit that result. And we're showing you the proof right in the result. We made this request and we got this response. And you can prove that out yourself and see that in this case, I think we reflected a script item back. That's one of the checks that we can do. But essentially these runtime, that's one of the powers of DAST, is that it tends to be low false positives, especially when deployed right next to the application. So you don't have mitigations, rate limiting, things like that, corrupting your scan results. So that's our answer, is depend on DAST to prioritize what to work on, and then integrate SAST to help the developer fix that vulnerability. It's a great question. We have about 10 minutes left. I did want to mention that if anybody is going to reInvent, we have a happy hour, or it's actually a very happy hour because it's after dark. And it's at the Chandelier from 9 to 11 PST. And it's sponsored by us and GitHub and Opsera and Modus. And if you show up, we'll have lots of representatives there that can talk to you about all of the stuff that you've seen here. Anybody else? Morgan, are you going to be there?
Yes, I will be there. I'm really looking forward to it. It's on Wednesday night, I believe.
Nice.
Well, we've got one more question, I think, from Andre. Are we serving the mid-market, enterprise, or both?
Yes.
I think I would say yes. We have customers anywhere from mid-market to Fortune 100, and are able to support them, especially as organizations grow. The need to be able to scale their DAST testing becomes even more important. So, and we're able to really keep up with that that scale with our scanning technology.
Got another one in the chat. How do you manage the mapping between the SAST issue and the DAST issue? That's a great question. And it's relatively simple. So we catalog, or we always check the CWE 89, or we always report the CWE, the common weakness enumeration. Because it's dynamic, there's not a known vulnerability. It's a weakness. It's a generalized weakness. This one's a CWE 89 that maps to SQL injection. CodeQL also does that. So we're just matching on that CWE enumeration. And next question might be, could there be a mismatch? Could they be unrelated? And yes, they could be, but generally they are the same. That's what our customers tell us anyway.
We got one more in the Q&A. How do we handle security in CI/CD pipelines where ephemeral environments and infrastructure as code are prevalent?
To provide real-time feedback for vulnerabilities introduced by infrastructure changes along with application vulnerabilities. So that's a complicated question, Alexandra. That's a really good question and a complicated one. So your test environment in the CI/CD pipeline is going to be different than your production environment. Usually, what we're really shooting for is a very pure view of the application, absent all of the mitigations that might be in place. So we want you to be testing in pre-production environments where you don't need those mitigations. And in fact, you don't want those mitigations because you want a pure view of the vulnerabilities in the application. So generally, there could be differences with that and the production environment, but generally the view you get is going to be more pure in that pre-production environment in the CI/CD pipelines. And we do want to provide real-time feedback. If you instrument it in PRs, that's one of the big benefits, is you get really fast feedback to developers. As soon as they commit to that PR, something that's vulnerable, we'll let them know. Any particular verticals? It's interesting.
I think, yeah, we're not necessarily vertical focused, but we do have customers in a lot of fintech and healthcare. Folks who have, compliance are obviously drawn towards these types of tools, but we serve a very wide variety of verticals. So pretty much anyone can use our software.
Anybody that writes software, and everybody writes software these days. What strategies does the integration employ to ensure thorough security coverage in scenarios where applications are deployed across hybrid environments, such as a mix of on-prem, cloud, and containerized infrastructure? Great question. What we like to see is you're testing individual components of your entire stack. So especially in microservice environments, it works very, very well to test just each microservice independently. And that way you get good, fast scans of each one. You can get a very complete scan of each one very quickly. And you can use test data for that microservice, for instance, to make sure that you've got a good real-world case. And you can use some of the advanced features of StackHawk to get very, very deep into that API and to take into account your seed data so you can get deeper into the API than you could if you didn't know anything about the data in your application, the state that you set up. So great question. We've got it's a deep topic, but maybe like get an individual demo and we can talk about that in more depth. All right, we should probably wrap it. Oh, we've got an actual script question. I want to tell the
Yeah,
scan.
that might be a good one to handle offline if you
Yeah, good call. Good call. We've only got 5 minutes left. We should probably wrap it here, but
Yeah.
send that to us.
I do
guess-
see some questions about the lunch gift card. Those will be randomly selected after this session, and you will be notified via email. So over the next few days, I'll be the one handling that myself, and I'm actually headed out traveling for the rest of today. So over the next few days, just keep an eye on your email, and we'll let you know if you are one of the winners. Thank you, everybody, for attending. Thank you, April and Brian, for the presentation. And if you have any other questions, please feel free to reach out to us via the website or via email, whichever you prefer. And we look forward to continuing the conversation.